Welcome to homework lecture number 3. Here we're going to be talking about equations, expressions, how to solve equations, and a couple of word problems. So I'm going to start off with the homework examples and kind of work our way through the homework and take a couple of examples from each type of question and leave some up for y'all to do by yourselves. So let's talk about what we were doing before this. We were learning how to simplify expressions such as this. If I have like this is called an expression. And the last one I said it's an algebraic expression, same thing. We would simplify the like terms and put them together. So 4 plus 3 makes 7, and then minus 7x would actually make 0x. 2 plus 3 would make 5. So we have 0x plus 5. 0x, since it's 0x's, we actually don't need it. Our answer would just be 5. So we learned how to combine like terms with these. Now, what we want to do is have a tool for any kind of simplification process. So let's look at this problem from number 1 on the homework. This is for homework 3. It says to simplify 3 parentheses 6x minus 2. Now remember, if the number is next to a parentheses like that, it means multiplication. What we cannot do is we cannot put these two together on the inside because they're unlike terms. They're x and a number. So what we need to do is get around it by using something called the distributive property. So distributive property. I like to sound it out. The distributive property says this. If I have a number on the outside multiplying with numbers on the inside, what we can do is we can distribute that term to everything on the inside. So that would then become a times b plus a times c. Essentially, we're doing this multiplication right here twice. We're distributing it to the a and to the b. So we multiply it with both of them. So we can do that with an infinite amount of numbers on the inside. If it was a times x plus y minus z, well, we can go ahead and multiply all those out. So we can distribute the a to the x. Oops, wrong tool. A to the x, a to the y, and a to the z. And that would give us ax plus ay minus az. Remember, a positive times a negative would make a negative. So we still keep those rules of positive times a negative. So looking at this example, we can distribute the 3 to the 6x and 3 to the negative 2. 3 times 6x would make 18x. We just multiply the 3 and the 6 and keep the x. And then 3 times negative 2 would make negative 6. And that would be our answer for number 1. So it simplifies into that expression. If I did number 2 from the homework, negative 3 times x plus y, again, we're going to distribute this negative 3 to the x and to the y. So this gives us negative 3 times x makes negative 3x. Negative 3 times y makes minus 3y. And that gives us our answer. It's pretty straightforward in the sense of how to distribute as to everything on the inside. Lastly, we'll look at number 3. This one's interesting. 8a minus 2b times 11. The 11's on the right side of the equation, but we would still distribute it the same way. There's really 2 ways you can look at distributing. You can say the 8 and the 2 to the 11, or the 11 to the 8 and to the 2, but it ends up making the same thing. So let's do the 11 times 8. That will make 88a. And then the 11 to the negative 2. That makes minus 22b. And there you have it. That gives us our simplified answer. So you can do this with simplifying certain expressions. You get a couple of them that are a bit more difficult in the homework. And I'll show you one more from the homework that involves multiple steps, which would be number 6. Wants us to simplify this expression. So to simplify this, we have 2 sets of distributive property that we need to simplify. We distribute the 2 to both of these, and then the 6 to both of those. We're going to have to perform it twice. So 2 times 2x for the first one would make 4x. 2 times -1 makes -2. So this part is this part that we just did. Now we need to distribute that 6 to the x and to the -3. So remember, this plus sign right here means positive 6. So if that was like a minus sign, it would be like a -6. So positive 6 times x makes 6x. Positive 6 times -3 makes -18. So what we just did is we simplified our expression a little further, and now we're back to what we learned in homework 2, which is combining like terms. I can combine the 4x with the 6x, and I can combine the -2 with the -18. So 4x plus 6x makes 10x. -2 minus 18 makes -20. There's your answer. So we use that distributive property to solve multiple expressions or to simplify them a little further. And we need to know how to do the distributive property to do something with solving equations, which is what we're talking about next. So right now, let's look at the difference between an expression and an equation. Now, when we have an expression, say I have something like x plus 11. This is called an expression, as we've gone over. It's just a set of terms and numbers put together by pluses, minus, multiplication, exponents, whatever it is. And then say I have something like x plus 11 equals 4. This now becomes an equation. All these equal signs that I've been using in the very beginning, I have this equal sign of the for the first part and then the second equal sign. That's me simplifying an expression. So I put that equal sign to show, hey, all of this becomes this, and then all of this becomes this. So we are simplifying the equation or the expression. But here the equal sign is in the very beginning. It's an equation right away. So what we do is we simplify equations and then we solve them. So with expressions, we're usually going to simplify expressions like we just did above. Usually there'll be simplification processes. For equations, we usually want to solve them. And what that means is we try to find a number right here that makes the equation true, meaning what number plus 11 makes it equal to 4. So let's try like a little example. I'm going to make up one. Let's say I have x plus 1 equals 3. And the instructions are to solve. You can look at the x number and wonder what number here plus 1 would make it equal to 3. Intuitively, you have 1. How many more does it make, or how many more do you need to make 3? You need 2 more. So x should equal to 2. That would be something called your solution. We know this needs to be 2 in order to make it true. But not all of them are that simple in terms of like thinking of them intuitively. Sometimes we have large numbers. So what we want to do is when we're solving this equation, I'm going to take the same exact thing. We want to be able to move things across this equal sign right here. Whenever we're moving numbers around on the equation, what we're going to do is try to get the x by itself, meaning I want to get rid of this 1 right here. It's in the way. I want it to have x equals some number at the very end. And in order to do that, this plus 1 is in the way in order to get x equals some number. So whenever we're moving numbers, I want to get rid of this positive 1. So it's a plus 1. To get rid of a plus 1, what I want to do is do the opposite of the plus 1. The opposite of plus 1 is minus 1. So what I'm going to do is subtract 1. I'm going to subtract 1 right here because that will make it equal to 0. Now the rule for equations in order to keep them balanced is what you do on one side of the equation, like this side, you have to do to the other side of the equation. So you can think of it as some line of equality. What I do on one side, which is right here, I have to do on the other side. I have to subtract 1 on both sides. It's kind of like, if you're growing up and you have a sibling like I did, if he got a raise in his allowance and I got a raise in my allowance, I would expect it to be equal if we did the same amount of work. So if he gets more, I should get more. Hypothetically, it just really depends on the familial situation. But in theory, you want to keep things balanced. So if I subtract 1 on one side, I have to subtract 1 on the other side. Think of this equal sign right here as your line of equality. So what happens here is the plus 1 and the minus 1, x plus 1, and then if I subtract this becomes 0. So my next equation becomes x plus 0 equals 2. Now, we know by the property, the identity property of adding and subtracting with zeros is that x plus 0 would just make x. So x equals 2 would be our answer for that problem. And that's how you solve the equations. So let me make up another one. Let's say we're solving, and I can use any variable I want, y minus 2 equals 4. So intuitively, you might see what the answer is. It should be 6 for y. 6 minus 2 will make 4. But let's solve it algebraically. Now remember, this line right here is your equal sign. What you do on one side, you have to do the other. Now I won't draw this equal sign or this little line for all of the problems. I'm just showing you as an example. If you want to do it on your homework or quizzes, you can. It's a helpful visual aid when learning. But after you get the hang of it, you'll most likely get rid of it. This time I want to get rid of this minus 2. So to get rid of a minus 2, we have to do the opposite of minus 2, which is plus 2. So when I add 2, that's going to become 0. What I do on one side of the equal sign, I have to do on the other side. So remember, this is our line that divides it. What's done on one side has to be done on the other side to keep the balance. Now, minus 2 and plus 2, that becomes 0. So instead of doing this, like on this last problem where it becomes 0 and then it just becomes x, we can skip this part because we know right here x plus 0 is just going to make x. And what we'll normally do is we'll just put a line through these two right there. Plus 1 minus 1, that slash means it becomes 0. So that's what I'm going to do on this other part. Minus 2 and plus 2, slash it through. It's implied it becomes 0. And you might have heard it from other teachers, it cancels out, quote unquote. Then it becomes y equals 4 plus 2 right here, makes 6. And that would be your solution. Let me make up another problem. Let's say we have 4 plus z equals 5. Here I move the numbers around, but remember our goal is to have z by itself. I want this guy to be by itself. So we need to get rid of the 4 somehow. To get rid of this 4, remember the sign that's in front of it is a positive 4. It doesn't have a little minus sign in the front. So since it's a positive 4, to move a positive 4, I have to subtract 4. What I do on one side of the equal sign, I have to do to the other side. That was a pretty ugly 4. There we go. 4 minus 4 cancels out. We're then left with z equals 5 minus 4, which is 1. Just like that. Again, if it was an example with a negative, if I had a negative on the outside. The opposite of negative 6 in order to get rid of it is a positive 6. So I would have to add 6 on both sides for that to cancel out. And that gives me x equals 8. That would be our solution for that problem. So let's go ahead and do some of the homework problems that relate to some of this. I already did like a couple of examples that are like the homework, but let me do one more. We'll do number 9 on the homework. Okay, so number 9 on the homework says to solve. And wants us to solve negative 19 plus x equals 9. This is just like my above example. If we need to get x by itself, we need to get rid of the negative 19. To get rid of a negative 19, we're going to go ahead and add 19 on both sides. Those cancel out. You're left with x equals 28. And that's your answer. So these are all what we call one-step equations. So if we look at number 11 on the homework, it's a little different. It's got extra steps in it. It still wants us to solve, so we're still going to solve. It says 4x minus 9 equals 3x plus 1. A lot more numbers involved. So what we want to do with this kind of problem is we want to strategize. First, I want to look at everything on this side and this side individually. So like we want to look at 4x minus 9 and 3x plus 1 separately. Look at this side of the equation and this side of the equation independently. So I'm going to look at the left side. Is there anything I can simplify, meaning like combine on the left side to simplify it down, such as combine like terms, what we learned earlier? 4x and minus 9 cannot combine, so no, there's nothing to simplify. If I look at this side, 3x plus 1, there's nothing to simplify. So I leave that alone. Now we're going to go into what we call like the moving phase. That's very non-scientific. It's just an expression. What I want to do is have variables on one side of the equation and numbers on the other side. For example, going back to these, notice we ended up with a variable on the left side all the time for all 4 of the final answers. And numbers were on the right side of the equation. That's what we want to do for this problem. I want to get all variables on the left side of the equation and all numbers on the right side of the equation. So if I look at this, I have a 4x right here and a 3x right there. They're on opposite sides of that equation. So in order to move them, I need to do the adding and the subtracting thing, meaning I can move this guy over here, or we can move this one over here. But remember, when we move things, we use addition and subtraction. So if I want all the variables on the left side of the equation, I'm going to want to move this one over here. So when we move a 3x, it's a positive 3x, we are going to subtract 3x. What we do on one side of the equation, we have to balance it out on the other side. So 4x minus 3x. These cancel out. 4x minus 3x becomes x. And we bring down everything that we didn't change. We didn't change the minus 9, bring down the equal sign, and then bring down the 1. We didn't change anything with the 1. Now we have the next step. So what we did is we just performed one step. We currently have all variables on the left side, but this number and this number aren't both on the right side. So we want to move the negative 9 to the right side. To move the negative 9, we need to add 9 on both sides. And this now becomes x equals 10. And that would be your solution for this particular problem. So this is a multi-step equation. It requires about 2 steps to do. Some of the equations later on require more, and then if you take college algebra, they definitely require a lot more steps after that. So let's move on to the next type of example. We're going to just move on to solving different types of equations. Let's say I have 2x equals 4, and I want to solve that. Just making up this problem. Notice it's different from 2 plus x equals 4. Like if I was to solve this one, like we did earlier, 2 plus x equals 4. Well, to move the 2 out of the way, I need to subtract 2 on both sides, and that would give me x equals 2. But here, this is an addition. 2 and x means 2 times x. So remember, here we've been doing the opposite, right? Positive, if we have a positive number, minus on both sides. If we have a negative number, we add on both sides. So here, think about what's the opposite of multiplication. The opposite of multiplication is division. So in order to detach this 2 from the x, we need to divide by the 2. So I'm going to divide by 2 on one side of the equation. And then what I do to one side, I have to do to the other side of the equation. 2 divided by 2 becomes 1. That becomes 1x equals 4 divided by 2 makes 2. And then it's redundant. We don't need to put 1x. We never put a 1 in front of any variable because it's more stuff to look at. We just go ahead and write x. So x equals 2. That would be our answer. So if I had something like negative 3y is equal to 9, I need to get the y by itself. I need to detach it from the negative 3. So I need to divide by negative 3 on both sides. Now instead of going from here, 2 divided by 2 makes 1, and then 1x just makes x, we can skip this step and just cross them out and know that negative 3 divided by negative 3 makes 1. So ultimately our answer becomes y equals negative 3. And that will do it. So looking at number 13 in the book, it wants us to solve 11x equals negative 77. Well, in order to get the x by itself, we need to divide by the 11. So divide by 11 on both sides. Those cancel out. X is equal to negative 7. It's a negative 7 because a negative divided by positive makes a negative. Number 15 on the homework, a little different. Negative 54 equals negative 6m. Remember, we want to detach the number that's attached to the variable. So that's a negative 6. So to get the negative 6 off of the m, we need to divide by negative 6 on both sides, because we want those two to cancel out to get m by itself. Negative 54 divided by negative 6 makes a positive 9, and that's equal to m. So we get 9 equals m, which is technically our correct answer. Yes, all the other ones had the variable on the left side of the equation, but 9 equals m is the same thing as saying m equals 9. They mean the same exact thing. All right, so that's how you solve problems where they're whole numbers. But let's look at number 17. Number 17 says 3 over 7x is equal to 3. This problem is a little different. It has a fraction in the front. What we normally do to solve for fractions is, instead of dividing by 3 over 7 on both sides, that looks crazy, right? Looks kind of daunting. What we do instead is we multiply by the reciprocal, because if I multiply by reciprocal, it's going to make 1. The reciprocal of a number, let's say I have 2 over 3, the reciprocal, that's how it's spelled, is basically the fraction flipped over, which would be 3 over 2. If we multiply reciprocals like that, If we multiply them, they always become 1 because 2 times 3 makes 6, 3 times 2 makes 6, 6 divided by 6 makes 1. Or another way is we cross divide, meaning 2 divided by 2 makes 1, so they cancel out. And then 3 divided by 3 makes 1, so they cancel out, and that ultimately makes the answer 1. So what we want to do on this problem, in order to detach the 3 over 7 from the x, we're going to multiply by the reciprocal, which would be 7 over 3. What we do to one side, we have to do to the other side. Now, since 7 is here and 7 is here, and 3 is here and 3 is here, we can cancel those out because they're going to end up becoming 1. 7 divided by 7, 3 divided by 3. Then we'll ultimately be left with x on the left side. Now on the right side, you can do 3's cancel out because they're dividing, and that ends up giving you 7 as your answer. Or if you want, if you're not comfortable with doing that, you can go ahead and multiply these out. 3 times 7 makes 21. You still have the divided by 3, which you need to keep. And then 21 divided by 3 will end up making 7. So you can cancel them out and get 7 right away, or you can go ahead and multiply across, then divide. Whatever you're comfortable with, you end up getting the same answer for both of them. So what if your number is kind of funky looking, like number 18? It's a mixed number. Negative 7 and 1/2 z is equal to negative 15. We never use mixed numbers in algebra because they're hard to work with. There's no set of rules that we can use to get shortcuts. You do use them in cooking, right? You say like 2.5 cups or 3.5 cups of something, or 1.5 gallons of stuff. You know, it's easy because you can visually see it. But with numbers, like algebraically, it's hard to work with them because not all mixed numbers become nice numbers. For instance, like, yes, we could say 7 and 1/2 becomes 7.5, but 7 and 1/3 becomes 7.3333. It goes on forever, so it won't make an accurate number. So what we do is we convert them into improper fractions. So if I want to change any kind of mixed number into an improper fraction, we're going to do this. Let's say I have 3 and 1/3. In order to change that into an improper fraction, we first multiply, let me make this number a little larger to illustrate, 3 and 1/3. You will take the bottom number and multiply it with the big number. Take that result and then add it to the top number. So 3 times 3, we're looking here, 3 times 3 makes 9. Take that result, 9. 9 plus 1 makes 10. So that makes 10/3. If I had, let's say, 2 and 1/4, 4 times 2 makes 8. 8 plus 1 makes 9/4. If I say 8 and, let's say, 2/3, 8 times 3 makes 24. 24 plus 2 makes 26/3. And that's all there is to it. So what we want to do for this particular problem right here is change that into an improper fraction. 7 times 2 makes 14. Plus 1 makes 15. And we're just going to keep the negative sign. So that makes negative 15 over 2z is equal to negative 15. Now what we want to do is multiply by the reciprocal, just like we did above. We're going to multiply by 2/15 on both sides. I'm going to just kind of separate this. 2/15 on both sides. But we also need to account for the negative sign too. So we're going to put a negative and a negative, because a negative times a negative will make a positive. 2's cancel out, 15's cancel out, and the negatives cancel out. You'll be left with, z equals. Now let's look at this. Negative times a negative will make a positive. We know we're going to get a positive answer. You can see the 15s cancel out, so you'll just be left with a positive 2 as your final answer. All right, so that's solving equations. We learned the addition and subtraction method. Then we learned the multiplication division method. Now we're going to put all of them together. So what we want to do is solve equations with multiple steps. Let's look at 19. 6x minus 4 equals 50. So again, our goal is to have all variables on the left side, all numbers on the right side. As we see, we have all the variables on the left side. Not all the numbers are on the right side, so we need to move this guy to the right side. So to move a negative 4, we need to add 4 on both sides. That gives us 6x equals 54. Now, on all those other problems, when we moved a number, we had x by itself already. Notice x is not by itself. Since you have all variables on the left side and all numbers on the right side already, we now need to detach that 6 from the x. To do that, we divide by 6 on both sides. And that ends up giving us x equals 9 as our final answer. So the cool thing with all of these algebra problems is that you can check your answers. So if you wanted to check your answer, let's say we're going to check x equals 9, we're going to take our original problem and we're going to substitute the 9 into x. So 6 times 9 minus 4 equals 50. Does it equal 50? So 9 times 6 makes 54 minus 4. Does it equal 50? 54 minus 4 is 50 equals 50. Yes, it does. So that means this answer is correct. You know you are correct as long as you handled your algebra correctly when checking it. Okay, let's try number 20. Once this is solved again, negative 18x equals 18x minus 24. Looking at this equation, I don't have all the variables together, but I do have all the numbers on the right side of the equation. So we need to move the variables to the left side. So what we're going to do is subtract this 18x and move it to the left side. Minus 18x, minus 18x. We now have negative 18 minus 18 makes negative 36x equals negative 24. Now we need to divide by negative 36 on both sides. Divide by negative 36. And we end up getting x equals a negative divided by a negative makes a positive. So it'd be positive 24 over 36. Don't go on your calculator and do 24 divided by 36. Yes, 24 divided by 36 will make 0.666 repeating. It goes on forever. We want exact numbers. So what we can do to simplify this fraction is find what we call the greatest common factor, or the greatest common multiple, rather. So what we can do is, what's the largest number to simplify 24 and 36? What's the largest number that goes into both of them? Well, say you don't know what the largest number is. Let's take the 24 over 36 and simplify it down here. We look for one number that goes into both of them. We can start easy. Both of them are even numbers, so the number 2 goes into both of them. So we can divide 2 into both numbers. 24 divided by 2 makes 12. 36 divided by 2 would make 18. Then if we look at the numbers again, I'm like, oh, well, they're both even numbers again. If I want to, I can divide them both by 2 again. That gives me 6 over 9. 6 and 9, there's still one more number. That number happens to be 3. 3 can go into 6 and 9. And that simplifies to 2 over 3. So ultimately, x equals 2 over 3. So you can do all these little increments right here to find the simplified answer. Now, the largest number that went into both of them, if I wanted to simplify it in one step, happened to have been 12. If I divide by 12 on both of them, 24 divided by 12 makes 2. 36 divided by 12 makes 3. And how I can find that out, you find it out through experience just by finding numbers. But also, if we look at each one of these numbers right here, if I multiplied all these numbers, 2 times 2 times 3, if I multiply all of them, 2 times 2 times 3 ends up making 12. That would have been the largest number that goes into all of them. So simplifying fractions, it's kind of like an art. You get it through experience. By doing stuff over and over again, you'll get the hang of it. All right, let's do number 22. Okay, it wants to solve it. This is 18 minus 2x equals 3x plus 3. Now I have numbers and variables on opposite sides. So we're going to take turns moving each one. I like to move the variables first and then the numbers. So let's put all the variables on the left side. So I need to move the 3x. Let's subtract it. What I do to one side, I have to do to the other. Rewrite everything you didn't change. 18. Negative 2 minus 3 makes minus 5x equals, those canceled out, positive 3. Now we have all the variables on the left side. We need to move the 18 over on the right side. Subtract 18, subtract 18. That gives us negative 5x equals 3 minus 18 is negative 15. Now we have variables and numbers on separate sides. We can finally divide by negative 5. And that gives us x equals positive 3. So that one took multiple steps. That had 1, 2, 3 steps in total compared to what we had earlier. So oftentimes with math, we want to translate sentences into equations. So I'm looking at 25. Y'all's numbers might be different on number 25. Actually, all these problems, the numbers might be slightly different, but the problem is still handled the same. On mine, it says to translate the English sentence into an equation using the variables indicated. It says Chan weighs 43 pounds, I'm abbreviating, pounds more than Ellen. It wants us to use C for Chan, so I'm going to say C is represented by Chan, and it wants us to use E for Ellen. It's good practice to label them like that at the top. This way, whenever somebody looks at your algebra, they can see, oh, how is everything labeled? What we need to do is label this as an algebraic equation. So Chan weighs 43 pounds more than Ellen. So when you're comparing the two, there's different ways to look at this problem. If I'm saying Chan is 43 pounds more than Ellen, I could write it like this. I could say take Ellen. If I add 43 pounds to her, that then equates to Chan. So whenever I'm reading this, I can say Chan, this part, is 43 pounds more than Ellen. It translates completely fine. Of course, you could have written it as C equals E plus 43 as well. Doesn't matter which side the C is on. So C is equal to E plus 43. Chan is 43 pounds more than Ellen. That would be a correct way to write it. Another way is you could think, oh, what if I take Chan's weight and subtract it from his weight to get Ellen's weight? You could do that. You could say Chan minus 43 is equal to Ellen. That makes sense. Or rather, you could say Ellen is chan minus 43. Both of them make sense. And when we're talking about algebraically, this makes sense, right? ln plus 43 makes chan, or chan minus 43 makes ln. If I was to apply some of those algebra rules, like moving the positive 43, I could move the positive 43 over on the other side. I don't combine it with the c, but I combine it with the 0 that's right there. That ends up getting us e equals c minus 43, which is what we have right there. So we move and we manipulate the equation. Either or, they're both correct. So that's the thing with math. Some people might approach an answer a different way and get the same answer, or the answer might look slightly different, but it means the same thing. These are both technically correct, but I mean both is like this one and this one. And then their counterparts. So either or are all correct. So that's what I want you to do on some of those homework problems. I want you to write out an equation. It doesn't ask you to solve for it. Notice in the instructions that say, what is Chan's weight? What is Ellen's weight? We can't find those answers out because it didn't give us any numbers like their combined weight or anything else. We need more information. The rule with solving equations is if we have two unknown variables, we need two equations to work with. So this is only one equation. It's just written in different ways. So it's still technically only one equation, just written in different ways. So we need some more information like, oh, their total weight is this. So if I have their total weight and I know Chan is 43 pounds more, I can figure it out. So what we can do is we can actually solve this problem right here. This is number 29 on the homework. It says a 12-foot board is cut into two pieces. So we're slicing that piece of board. It says the longer piece is 5.5 feet longer than the shorter piece. All right. It says, what is the length of each piece? So now it wants us to find it. What is the length of each piece? Here it wants us to actually find it. So on the other problem, if it would ask what is the weight of both of them, we'd have to find the weight. On the other problems, they just wanted the equation. This one, we're going to need equations in order to solve it. So what we need to do is we need to create some equations. Erase all this. So what we can do is interpret some of this. All right, so it says we have a 12-foot board and it's cut into two pieces, which is a longer piece and a shorter piece. Let's label it. We'll say L is the longer piece. And then we'll say S is the shorter piece. Now you can use X and Y, A and B. It doesn't matter what variables you use. I just like using the same letter as the first letter of the word so we can see what's going on a little easier. I don't have to refer back. But again, we labeled them in the very beginning so we know what we're talking about. So if I take the longer piece and the shorter piece and put them together, that makes the whole entire board. So if I say S plus 11, that would make the whole board. The whole board is 12 feet. So S plus 11 equals 12 would be like my first equation. My second equation I can figure out from what's given to us. It says the longer piece is 5.5 feet longer than the shorter piece. So the longer piece is 5.5 feet longer than the shorter piece. S plus 5.5. If I take the shorter piece and add 5.5 to it, it makes the longer piece. So we currently have two equations with two unknown variables. Two unknowns, two equations. Perfect. We can solve for each individual variable with this. What we're going to do is we need to learn something called the substitution method. So here, I have L by itself. We've only learned how to solve equations if they have one variable in them. So like we had them all, they had X, Y, or Z, but they didn't have any other mixed up variables in there. What I want to do is instead of saying S plus L, we're going to do a substitution. Instead of writing L right there, we're going to take this guy and substitute it into there because L is equal to S plus 5.5, meaning it's the same thing. Think about like currency. Like I don't know what the current exchange rate is for like, euros and dollars and pesos, but let's just say, the ratio to the dollar and the peso is 20. So $1 is equal to 20 pesos. Again, I don't know if that's what it is right now. I haven't checked Google recently, but that's an equation, right? I can either pay with, if they accept both currencies, I can pay with the dollar or I can pay with the 20 pesos. It doesn't matter which one I pay with, they're the same thing. So here they're the same thing. L and S.5.5 are the same thing. So instead of putting S plus 11 equals 12, we're going to put S plus 5.5 equals 12. Right here, that was our L. Change the L to S plus 5.5. Now we see that our equation has only S's in the equation. We start solving like we did before. Look at the left side. We can combine the two S's, which makes 2S plus 5.5 equals 12. All my variables are on the left side. We just got to move the numbers to the right side of the equation. So we need to subtract. We're going to do minus 5.5 on both sides. And that gives us 2S is equal to 12 minus 5.5 is 6.5. Then lastly, to get S by itself, we need to divide by 2. And that gives us S equals 3.25. So we currently have a crucial piece of information. S is equal to 3.25. That's the length of the shorter piece. Now we need to figure out the longer piece. We can plug in our S into either the first equation or the second equation to get the answer. Now I like using this one because it will give us the L right away. So L is equal to S plus 5.5. We figured out what S is. Instead of writing S, we're going to put 3.25. 3.25 plus 5.5. And adding those two together, we get 8.75. L is equal to 8.75. And that would be our answer. The longer piece is 8.75 feet. Shorter piece is 3.25 feet. And yeah, you can see them right here too. Those are fine to put as well. I would understand that on an in-person exam. It'd be fine to put that answer. And remember, you can check your answer. 8.75 plus 3.25. If you add the two pieces together, it does make 12 feet. And if you took the shorter piece and added 5.5, it would equal the longer piece. So 3.25 plus 5.5, what we did in the very beginning, does make 8.75. We end up getting the correct answer. All right, so the last thing for the homework is talking about commission. So let's look at number 31 on your homework. For my numbers, they might be a little different than the ones that you come up with, but they will be similar. Here it says a saleswoman at a car dealership earns $1,200 per month plus 9% in commission on her sales. It says last month she earned $8,040. It's asking what was the amount of her sales. So when we look at this problem, this is what she earned total. And remember, that number is dictated by how much she gets per month and the commission rate. So first, what we have to do is take away that 1,200 from the total sales that she got. So we do 8,040 minus the 1,200, because she earns $1,200 regardless if she makes any sales or not. So that number 8040 includes the 1,200. So 8040 minus 1,200, it gives us 6,840. This number right here is her commissions, not her monthly payment that she gets. So we need to figure that out. Usually commissions are your sales times your commission rate equals your commission. If you worked at a clothes store or something like that, that's how you figure out your commission. Sales, if you worked any kind of sales job, that's how it's figured out. It's similar to how tip is calculated, right? It's the sale of the bill times the tip percentage equals the tip. So what we currently have in this formula right here is we have the commission, which is 68.40. We have her commission rate, which is 9%, and then we don't know her sales, so we'll call it X. 9% as a decimal is 0.09. And 0.09 times X, we can just rewrite as 0.09 times X equals 6840. As you can see, we need to divide by 0.09 on both sides. Even though it's a decimal, we still divide by the decimal on both sides. That ends up giving us X equals $76,000. So that's her sales from last month. So you had to calculate the commission, and then the 1,200 would go on top of that. So we essentially had to work backwards for this one. All right, well, that wraps it up. Number 32 is kind of similar to number 31, so I'll leave that one up to y'all. That wraps up everything for homeworks 1 through 3, and that wraps it up for quiz number 1. So go ahead and look into taking the quiz 1 online on My Math Lab. It'll be up there. All right, so go ahead and finish up this homework. Make sure you got everything down, and then go ahead and do the quiz.